Hello everyone, this is Srividya, Assistant Professor, Department of CSIT. In this session, I am going to talk about dynamic memory allocation in C. So this is the overview of the session. Before discussing the dynamic memory allocation, let's see what is static memory allocation and what are the functions that we used in dynamic memory allocation. So first, before starting the dynamic memory allocation, let's see what is static memory allocation. What is static memory allocation? Suppose if I declare like this is what? Array declaration. Int is a data type, A is an array name, and 40 is the size of the array. So this is what? The array declaration. If I initialize this one, let's take the compile time initialization. Int A is equals to 40. That's it. Only 6 values were there. But int 40 is the size of the array. I have mentioned 40 into 2 means 80 bytes. We are asking for 80 bytes, the compiler, to reserve some space in the memory to store these 6 integer values. Rest or all, you are wasting your memory. So because you are storing only 6 integer values, but here the size you have fixed as 40 bytes. So 40 into 2, 80 bytes of memory was reserved for this declaration, but rest of all the values or space will be wasted in this case. Or else, let's take one more example. So this is the compile time initialization of a string. So here what I have taken, data type as char, name is the array name because string is an array of characters. Name is an array name and 30 is the size of the string and my string is here MLRIT. So how many characters I have taken? 1, 2, 3, 4, 5. Only 5 characters to store the string MLRIT. But the size I have declared here as 30. So rest of the 25 bits, whatever the data I have taken bytes, all are wasted only. So to avoid this one, this is what? Static memory allocation. This comes under static memory allocation. See, means at the time of you're fixing your memory. So at compile time only it is fixed. So how many bytes of data you are required, that you are telling to fix at the compile time itself. So memory is fixed at the time of compilation itself. So to remove these drawbacks, we have dynamic memory allocation. So before starting the dynamic memory allocation, let's see the memory fragment. So what is this memory fragment? So while recursion, I have discussed this stack. So here it is code or text, global or static, stack and heap. Okay, so stack grows in this direction and heap grows in this direction. So what is stack? All the local variables takes the memory from the stack. Heap is a big pool of memory. So now what is dynamic memory allocation? Memory that can be allocated at the time of execution is called dynamic memory allocation. See, memory will be allocated only at the time of execution. That is called dynamic memory allocation. Memory will be only allocated at the time of execution, and stack part is very less in size. Stack memory is very less in size, but heap, it's a big pool of memory, and all the local variables takes the memory from the stack. So what is dynamic memory allocation? Let's see the functions of dynamic memory allocation. Memory that is allocating at runtime, and these are the 4 functions of DMA. These are the 4 functions of the DMA. We have malloc, calloc, this is memory allocation. Continuous allocation or contiguous allocation. Reallocation and free. Let's see this one. Malloc. So what is a malloc function? So before starting this one, this is your heap memory, and suppose if I write like this. In the previous case, in static memory allocation, what we have seen, int a, this declaration, int a of 50. 50 was the size that is fixed, but the values which we have taken only 5. Only 5 values we have declared in the array, and rest of all the space were wasted in the memory. So to avoid this one, we have dynamic memory allocation. And dynamic memory, if you want to allocate the memory dynamically, these are the 4 functions we have seen. So now I am going to discuss malloc. But how you will allocate the memory dynamically? Dynamic memory allocation is done from the heap section. DMA is done from the heap, and we need pointers. So to access this one, we need pointers. So this is one of the application of the DMA. Suppose if I write like this, let's see if the first function malloc, memory allocation, malloc of 8. So malloc of 8 means, so you are telling I need 8, I want to store only 8 or 8 elements or 8 data values in the heap section. So here the space will be allocated here. Let's see the syntax of this malloc. Void pointer malloc of malloc of size in this code t size. So this is unsigned integer. So what does it mean? This is unsigned integer. And what is void pointer? See, whenever you are asking the compiler to allocate some space in the heap section, so dynamically you are allocating you want to allocate some memory in the heap section to store your data values. But malloc doesn't have any idea what kind of data the user is storing in the heap section. So that's why it will give you the void pointer. So what is void pointer? Void pointer is generic pointer. Void pointer is also called the generic pointer. Means it is not associated with any data type. Later you have to typecast this void pointer to the required data which you are storing there. See, void pointer is also called the generic pointer. So why it will return void pointer on success? Why it will return the void pointer? Because malloc doesn't have any idea. The space will be allocated in the heap section, but it doesn't have any idea which data, what kind of data the user is storing in the heap. So that's why it is void pointer. Later you have to typecast. So on success it returns pointer address, on success it returns the pointer base address, if not null. On success it returns the pointer base address, if not null. See, this is the example. In pointer A, pointer variable is declared and A is equals to int pointer malloc of size of int. So I want to store only 5 integer values in the heap section. So what I will do, I will typecast. So void pointer, because first it will give you the void pointer because it is not associated to any type. Later you have to typecast to int pointer. Example, int pointer malloc of n into size of int. So n into size of int. See how many number of integer values I want to store, that many bytes will be reserved in the heap section. So malloc will allocate the memory dynamically only at the time of the execution. Suppose if I want to use only 5 elements, my n value is only 5. So int pointer n into 5 into size of int. Size of int. So this is left to the compiler itself. If integer size is 2 bytes or 4 bytes, it will substitute and give you the space there. So size of integer is, let us consider 2. So 5 into 2. So 10 bytes of memory will be reserved. Ten bytes will be reserved in the heap section. So this is char. Another example, char pointer malloc of size of char. The return type is void. The default value stored is garbage value. So if not initialized, the default value of malloc will be the garbage value and n is the number of blocks that is allocated. So this is the syntax we have seen, and this is the sample program. Read and print 1D array elements using the malloc function. So hash include stdio.h, and one more thing, all these 4 functions whatever we are using in dynamic memory allocation, all these 4 functions will be in std lib.h header file. Read and print 1D array elements using malloc function. Hash include stdio.h. We are using malloc function, so the header file is stdlib.h, and a pointer variable is declared in pointer a, int n comma I. Enter the number of blocks. See how many blocks of data you want to store or allocate in the heap section, that many number of blocks will be allocated. Depends on your choice. It is asking you to enter the number of blocks in the runtime. A is equals to int pointer malloc of n into size of int. So we will take the for loop. For I is equals to 0, I less than n, I plus plus scanf %d comma a plus I. So why we are not writing address of a plus I here? See, you should not use any arrays here, because that if you use like this, like if you declare an array like this int a of 50, that will be the static memory allocation. It comes under the static memory allocation concept. So to avoid this, only we have gone for this topic, dynamic memory allocation, and we are using the function malloc cloc. With malloc and cloc, both you can allocate the memory dynamically. Okay, so it is why we are not writing the address of operator address of a plus I here, because already pointer contains the base address. So if it is on success after creating your allocated block of memory in the heap section, on success it will return the pointer base address, means the first byte address of the memory. So pointer knows the address, so no need of giving again address of operator in the scanf function. So this is what the input. For I equals to 0, I less than and I plus plus. 0 less than, suppose let us consider I want to enter 5 blocks of memory. So 0 less than 5, condition true, control will enter inside the block. This is for loop, entry control loop. Once the condition is true, the control is here. So A, the base address. Let's consider the base address as 1000. So A, base address. So how it will be the representation we have discussed in the last pointer session also. I is 0. So base A plus I is interpreted as base address plus number to be added. I value is 0 into size of the number or size of the data type required. So suppose let us consider int takes 2 bytes. 1000 plus 0 into 2, obviously it is 0. So at 1000 location, you will enter your first value. Next, I becomes 1. 1 less than 5, condition true. So 1000 plus 1 into 2, at 1002 location, second value. Next, I plus plus, I becomes 2. 2 less than 5, condition true. So 1000 plus, it is 1004. Location is 1004, the value will be 3. Next, I becomes 3. I becomes 3. I is 3. So it is 1006. Value will be 4. Now I becomes 4. 4 less than 5. So 1000 base address plus number to be added. I value is now 4. 4 into size of integer. It is bytes. 2 bytes. So it is 1008. So I am storing value at the location 1008 is 5. Next, 5 less than 5. 5 less than 5, condition false, control will exit from here. So these are your value. So how many bytes were allocated? No. So 5 values and the data was allocated. No wastage of space here in the concept of dynamic memory allocation. Same, you will print it. For I equals to 0, 0 less than n, we have used the printf statement and we have used this. So what is this one? You will get the value stored at that location. Value stored at the location, it is base address plus 0 into number of bytes to be added. 1000 plus this is 0. At 1000 location the value is 1. And next location, next answer will be 2. I will be incremented 1. Next 3 and 4 and 5. So like this you can read and print the elements of 1D array using malloc function. That's all for this session. In the next session we will see the rest of the functions of DMA. Thank you.